Awesome. So our next talk is by Soam from Stripe. I'm really excited about this talk because we have a couple of stories of how people have started their own CDEs in their companies, and Stripe is going to be super interesting. So I'll hand it over to you.
Thank you. Thanks, Pauline. Yeah, sound okay? All right. Yeah. So thanks for inviting me here to this talk, Gitpod folks. So yeah, I want to tell a little bit of the story of how Stripe ended up with what you call cloud dev environments. And we'll talk a little bit about the evolution of them and some of the good, bad, and ugly of them. All right. I think I can safely skip this. Most of you are pretty familiar with Stripe, payments infrastructure for the internet. The general scale of the problem from the dev environments point of view, there are about thousands of engineers, millions of lines of code, and I'm just going to dive straight into how the dev environments actually work. It's a pretty small group, so feel free to just interrupt me with questions anytime. So before we started any of our remote development or cloud dev environment story, our dev environments kind of look like this. There's sort of three important pieces of it. There's the laptop. That's where the developer keeps their source code. They run Git there. They run whatever editor they want. We've never really mandated any particular editor at Stripe. Each developer got an EC2 instance, and we rsync source code from the laptop into these instances. And we'll talk more about the architecture of that. And of course, there's quite a bit of infrastructure to manage all of these instances. We actually assign these to users. We have to destroy them when they're stale, and so on and on. All right. So a little bit before I go on about the tech stack that we're targeting. Stripe is more than a decade old, and a lot of our technology choices are, relevant to that time. So the majority of our source code is in a Ruby monolith, and at some point in sometime around 2018 or so, Stripe decided to make this a type-safe Ruby monolith. And so a project to create a Ruby type checker was born. It's an open source project. You can check it out at sorbet.org. I'll have a link later here. And Sorbet also provides editor support. Most of you are probably familiar as dev environment folks with LSP, the language server protocol. This is a protocol for that the editor can use to ask a language server to do things that are specific to the semantics of the language, such as finding the definition, finding references, even refactoring, renaming things, and so on. Given how large our source code is, it's not really feasible to run the LSP server on the laptop itself. Well, maybe you could give people really big laptops, but it makes much more sense to run this LSP server remotely on the dev box. So that's where that runs. And of course, the backend services themselves run in this dev instance. Over time, it's accumulated more and more of Stripe's infrastructure. You can think of it as giving each Stripe engineer a kind of mini Stripe that they can iterate on. All right. And so, yeah, there's a picture of that. This is a picture of one developer's dev environment. So there's the editor. It talks LSP to the Sorbet server on the dev instance. There might be other LSP servers too for JavaScript, Java, and so on. The source code is rsynced over to the dev box because everything that actually runs on the dev box needs the source code, including the LSP server. And then there is this thing, which actually watches all changes to the source code and lets you run services. It has an API, so you can, from your laptop, request it to start and stop various backend services, right? And you can then access those services. There's some network shenanigans we do to let your laptop browsers talk to the backend services here. Yeah, and so this is how our we call these dev boxes, dev environments, This is how they looked about a couple of years ago. So yeah, what works well about these? If you compare this picture to running everything on the laptop, it's a lot better, right? For one, you can get a lot closer to your backend services being production-like on an EC2 instance than you can on the laptop. So we get better accuracy. You can be much faster because we can give developers as much CPU and memory as we can possibly afford. And it's easy to justify giving more CPU and memory because it just makes every engineer more productive. An important bit is that it's stateful. You can leave this instance in a certain state. You can walk away in the evening, and the next morning it's in the exact same state. Assuming you're okay with paying the costs of keeping that idle machine on all the time, it's really convenient to be able to not have every developer like recreate the state every time they walk away from their dev environment. And a really important bit is that it's isolated. It's completely isolated. I can operate fearlessly. I can make any change without any fear of breaking somebody else's dev environment, right? And this property will become important in some time because we are going to break it. What didn't work well is multitasking. If you remember, if you look at the bottom part of this picture, we are syncing source code. This is great when you're making one file change at a time. But if you do Git checkout in a company that has several thousand developers, you're probably pulling down thousands of commits, changing thousands of files. Rsync goes crazy, starts syncing the whole world. The thing that watches services then observes so many changes that it then restarts every single service. And you kind of trigger worst case behavior when you switch branches in this architecture. So we never really liked the branch switching part of this design. And so we decided to move away from it. Let's stop for questions so far. Any questions about this? Yes. Language server protocol. It is so if you think about the editor's job, right? It's at some point people realize it doesn't make sense for every editor to implement jump to definition for every language. And a new language, I think they started with maybe TypeScript, right? So the folks building TypeScript realized that they could just build a server that has an API where you can ask it questions like, find me the definition of this function. And then editors can just call that server. There's a really interesting talk by the TypeScript folks about this and how they incrementally compile and actually keep the language server fast as you're incrementally changing source code. There are other talks also about how Sorbet does this and how Sorbet is fast at what it does. But essentially, we have a Stripe-built language server for Ruby, and we use other language servers for TypeScript. And I don't remember what we do with Java. But okay. Yes. Oh, I love this question. So your question is our model of working still correct? Like, given how expensive branch switching is with this model? I have a little bit of a quibble with your question. Like, I think in the remote dev case, sorry, I'm jumping around, which we'll talk about in a bit, I think branch switching does get a lot better. It is expensive in terms of raw like AWS or cloud cost. we will mitigate that a little bit. Let me come back to your question maybe after we talk about remote. That's exactly what we want to do. Yes. So yes. He's describing my next slide. Um, so uh, so yeah. So our old model is every developer gets one dev box. They treat it like this thing that they have to take care of. It lives for a long time, typically a few months before they get sick of it and replace it. And it rsyncs from the laptop. We pay this branch switching cost. We wanted to move to a model where you get one dev box per branch. It's ephemeral. We do the typical trunk-based development. You create a feature branch, your branch dies in a week or two, and we want you to just throw that box away after you're done. And basically never worry about branch switching again. So it's short-lived, few days to a week or so. There's no sync ever. This authoritative copy of the source code lives on this instance. And now you have to figure out how you're going to edit it. Okay. So let's draw that same picture. And the picture kind of looks the same, except the source code moved. So the editor is on the laptop. You can still have, your browser, your clients that live on the laptop, the ones that whichever you like and work with. The dev box has a service runner and it runs services, and it has the source code. I've split off the dev box from the EBS volume here because now note that we said we want many per developer. So now if you just have n of these per developer, you've multiplied your cost by n. So if you have 6 per developer and you had 1,000 dev instances before, you suddenly have 6,000 of them. We're kind of not okay with instantly multiplying our AWS bill by 6 or 10 or whatever that number is, which is why we split this from each other. And the insight is that even though users want to multitask, they aren't multitasking that simultaneously. You don't need every dev box running at the same time. You can switch off that yellow box, and the stateful part of the dev box can live on a volume. So this is what we did. We separated the volume. You can reattach it to a new EC2 instance. In fact, you can even change the size of the instance. You can switch it off, get a bigger instance if you want to run more services, attach it to the same source code volume. You can also keep the database there, which means your test data can outlast your the expensive part of your dev box. So if you think about the cost ratio, that yellow box costs about 10 times the green box. So that's the one we want to switch off. Does that make sense? Like, this is the sort of addressing the question you asked earlier. Like, isn't branch switching still expensive? Yes, kind of. We're still storing, the full copy of the source code for every branch that the dev is doing. But storage is kind of cheap. And as long as we switch off the instance that when it's not being used, we can still be pretty efficient. Okay, so what works well here? We retain all of the speed and accuracy. We removed our theoretical limit on multitasking as one, and you can have as many as you want. Practically, we still limit people to, forget the number, I think it's like 6 active ones or something. No, it's a few, 2 or 3 active ones, and then you have to suspend beyond that. But a really nice property is that, I know Gitpod users very familiar with this, you never have to set up anything locally. And as the team that's supporting thousands of developers all over the world, we really like not having to ask people what's on their laptop, what have they done lately, telling people on Slack to brew update something as a person like trying to get them working while they're blocked is just kind of horrifying. So it's really nice to tell them just click this button in your browser, start VS Code, and you're done. Okay, I won't talk too much about this. This picture is borrowed from the VS Code documentation. This is how VS Code itself works. So the local OS here, the box on the left is the laptop. The box on the right is what we call the dev box instance in our previous slides. And VS Code is actually really nice at doing this remoting stuff. All you really give it is an SSH configuration, and you tell it to run in this remote mode. and it knows what to do. So it SSHs to the box. It starts whatever it needs to start. It talks to the source code. Again, you have to configure that. And you can even run a terminal that you can see on your local VS Code that's actually running on the remote box. So we kind of got all of this for free without really having to do much work. I'm not sure why they draw a debugger box. We did have to do some work for the Ruby debugger. Yeah. So what works well? I think we kind of solved multitasking fairly well with this. Nobody really talks anymore about the branch switching cost of a dev box because they just spin up new boxes. That problem is now transformed to how fast can you give someone a new dev box, right? And that is where we have focused a lot of our optimization energy. VS Code works really well. There, we didn't have to spend much engineering effort on this. The idea of suspending and resuming has worked really well. Again, we have to spend some optimization energy on this work because when you throw away that instance and you create a new instance, it starts with completely cold caches. So every single operation is slow. That LSP server is going to cache miss on every single thing it does over tens of GB of source code. It's kind of excruciatingly slow to unsuspend a dev box. But the main thing is that it gave us a knob to dial between how happy users are and how much money we're spending. And so, if the economy is good and we, we can spend a lot of money, then we can make our users happier. Otherwise, we can tell them, well, we're saving money. Sorry, your dev box is going to be slow for the first 10 minutes. What doesn't? Editors other than VS Code. IntelliJ kind of works. We've been working with JetBrains folks. I like. It would be nice if we didn't have to work with every single editor, like on a case-by-case basis, and if they all worked magically. Maybe there is some possibility of standardization here for how editors deal with remote dev environments. I don't know if of any such standardization effort, if it exists. So yeah, before I jump into other things, any questions? Yes. Yes. So, sorry, what's the? Yes, yes. Good question. Yeah. So what stops developers from switching branches in this model? Nothing. They can SSH, they do, and they can run whatever Git commands they want. It's not. We're not preventing them at all. Some of them do this, but we see it as something that's wrong with our offering if they have to do that. Like, if provisioning of a new instance is so slow that people would rather go through the full pain of switching a branch on an existing dev box, and we've done something wrong. We've got to make provisioning faster. Yes, yes. Yeah. 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 That's true. Yeah. Yeah, that's true. I think another reason has been for us, at least, test data. If you spend a lot of time manually creating your test data, then you tend to not want to just throw it all away. That's a tough one. I don't have much slides for it, but most companies probably have some sort of automation around test data. What Stripe has is, instead of writing the test data, you write little bits of code that generate test data. And then we have sort of internal tools that can target any database in dev, in staging, and so on, and run those test data generators. So if people set that up, then a new dev box can come up with that test data. But I hear you. Like, a lot of the effort of moving people into the better experience is sort of changing how they think about that experience. Yeah. Yes, right. I think a lot of it is just making it faster to provision. If it takes like 10 minutes to get a new one, I'd rather just git check out. Right. Yeah. Yes. Yeah, good question. So for both the old and the new dev boxes, we keep a standby pool of dev boxes. None of the creation of this stuff is happening after the user has asked for it. That would be just far too slow. So all you have to do when a user asks for a dev instance is write a row in the database saying this instance belongs to this person, do some SSH config stuff that allows that user to SSH to that thing. And that's what we're good at. What we're not good at is pre-starting all of those services that are in a way that's specific to the user. So the user still has to wait some time for those services to start. It varies widely across the company how much time that actually takes. It can take 1 minute and then nobody cares. It can take 15 minutes and everyone's unhappy. So yeah. Okay, thanks. So yeah, it's an ongoing optimization effort. We would love to make it as fast as like opening a tab. Yes, they are EC2 instances. We have, yeah, I got a time warning, so I won't talk about our container efforts. But it's not top of mind for us, and I think almost all of the optimization efforts, they're possible with EC2 instances as well. So a big migration to containers, we did this in production at Stripe, but for dev instances just hasn't risen to the top of our priorities. But we can talk more about this. I want to talk a little bit, let's see how much I can get through, is that we've talked a lot about this one giant instance per developer. And there is a point at which this breaks. We started Stripe with like this giant Ruby monolith. We added 1 or 2 more monoliths to the story. There was one database. At that point, it kind of made sense to run everything in one instance. But we're not there anymore, and most companies aren't. There are hundreds of services, dozens of databases. There are asynchronous systems. There are cloud systems that are not easy to simulate on an EC2 instance. So what to do? We don't. So let me draw. Okay, one more thing is that we have this shared staging environment. Are there tricks we can do to actually leverage that in the dev environment itself? Okay. So let me draw a picture. Let's say this is this is the service that you're testing in the middle, and there are various other services that you need if you want to actually test the system end to end. It's arguable whether you should actually do this or whether you should only test your service. But if you're, for example, full stack engineer trying to change the front end and the back end, you kind of are forced to go through many services. All right. Now, if you're lucky, all of this fits in your dev box. And this is the model that we've been talking about for the last 15 minutes. But if you're not lucky, you kind of have to pull out some of these out of your dev box because they don't fit, or we just keep making our instances bigger. We have doubled the size of our instance so many times that we decided it's time to do something better. So, okay, we have a staging environment. It's a Kubernetes cluster. So those things, instead of like running in that one instance, they are now pods in Kubernetes. And those arrows are now, instead of being local networking, they're going through the service mesh that we have in the staging environment. This is possible. This is fairly doable. We have broken that isolation property. I can now break the staging environment, even though I'm not changing it, with some bad request. I can delete some test data that somebody else was using. We don't enforce anything here. People just kind of know that they're not supposed to do it. Not ideal, kind of works. The other thing you can do is completely ignore your dev environment, and you can just straight up deploy your branch into your staging environment. People do this, it's really bad because a branch hasn't gone through all of the qualification steps before going to production. And so you don't want to, now the thing about this service in the shared staging environment is that it's shared. Somebody over there on the left is using it as a dependency And when you changed it, you affected their workflows too. So this completely breaks isolation. We actually have locks in our deployment system for our staging environment to be able to do things like this. It's not great. So what we've recently done is that you can actually hijack a subset of requests. Okay, you can hijack some subset of requests into the dev instance from the staging environment. This works much better. All of the default traffic in the staging environment stays there. This lets us think about the dev box as a specialized tool for observing changes fast. It's only for the dev loop. It's not for running your full test environment. Yeah, and I'm going to skip a couple. Okay. It's all just, so our service mesh uses Envoy, but the control plane of Envoy is all custom to Stripe. And so we just, yeah. So this makes dev boxes smaller, and that brings all the advantages. It's generally more reliable, faster to set up. We hope to make them cheaper. We haven't made them cheaper yet. What doesn't work so great? Shared environments. We're still using them. Can get messy if somebody still breaks it. There's various things that aren't isolated very well. It's a work in progress. I'm going to skip 2 more slides, and I want to keep, if there's any time for questions. Okay. Okay. All right. Any more questions? Thank you. Yes. Hey. Remote. Yeah. Right. We're not forcing anyone to move. We are trying to incentivize them. So we do a lot of like nudging in the product itself, our UI surfaces. For example, when you do a branch switch and you're waiting for it to finish, that progress bar where you're really annoyed with it, that's a great time to tell you to switch. So that's what we do. That gets a lot of traction. We are something like a third of people have migrated. And the graph is nicely up and to the right. We're pretty optimistic. Especially for VS Code users. The migration has been mostly driven by users, and they're happy. Yeah. Yes. But it isn't okay. So maybe you could do that, but there's a few things. The diffs are just very big. So even with that integration, you would be paying some cost in LSP. The second thing is that LSP is the faster thing among all of our problems. It's rsync and service startup that's more painful. So yeah. We let people choose. I think we're either 32 or 64 GB in size. There might be one bigger size. Yeah. Yes. Right. Ooh. We spent some time looking at what Facebook has done here with, they virtualized the file system and built custom clients and servers for their version control systems that actually are much more efficient at monorepos. Stripe itself isn't at the size where we, can justify that kind of investment. So I think as monorepos get bigger, you kind of are forced into these kind of questions. So yes, maybe. Yeah. Right. All right. Okay.
Thank you so much. Thank you. Awesome. We'll give it like 2 minutes if you want to get refreshments, and then I'll get Nick's slides up now.